Martinez? No?
No, it wasn't me.
What? Ah, okay. Okay. Who speak? I need to know who make a favor. I appreciate so much this. Okay, you are shy. Suppose the example one, guys, super easy. 1 over x. It's a reciprocal function. Okay, suppose you very well know. Bueno, ¿es a rational function, professor? Well, yes, because a constant one represents polynomial degree 0. And x alone represents polynomial degree 1. Because it's linear. It's a line. Now, you, for example, you determine domain. Oh, it's easy. We learned that in the first chapter. Domain is you take the expression in the bottom, that one, and this expression never is 0. So basically is any value of the x such that x no 0. Okay? That was the first example, super easy. Everyone follow me? Example 2, a little bit more interesting, no? Is suppose we have in the top 5x squared, and the bottom we have x squared minus 5x plus 6. Okay. Now, one important thing you should do always in the analysis of the rational function is express the given function in factory form. Factory form. Factory form. What mean that? Factorization. You factorization the polynomial in the top, and you factorization the polynomial in the bottom. In the top, it's a monomial, stay the same. It's impossible to do anything. But in the bottom, yes, it's trinomial, and you break it down into binomial. And the combination is 3 and 2. Negative. It's a factor of 4. Now, entonces I see more clear. Okay, when expression in the bottom is 0, in order to find domain, is in positive 3 y en positive 2. Entonces, the domain for this rational function is all real numbers such that no 3 and no 2. By the way, I forgot to say that, but in this example, that value que to be undefined the function, in this case, are a vertical asymptote. Vertical asymptote. Maybe you don't remember or you don't understand what mean vertical asymptote. However, I want to refresh your memory a little bit now, but after when you study in detail vertical asymptote, I want to refer. For example, the reciprocal function, everyone know very well. Look like that. Look. It's like that and like that. And we have one vertical asymptote at 0. So we have here a vertical asymptote. It's a perfect coincidence with the y-axis. Okay, and you see that when you approach it, so when the x approaches to 0, maybe to the right or to the left, the y value of the function approaches to positive infinity or negative infinity. In this case was, when you approach it to the right, it's positive infinity because you see that the y value increasing positive, like that. And when you approach it to the left, it's decreasing, but in the negative direction. But don't worry too much for this because I want to explain in detail a few minutes, 2 minutes maybe, when I finish to present the example I bring of any possibility of the rational function. Okay, example 3 now. Example 3 now is another function. Is the division to thing. is x plus 3 in the top, x squared plus 4 in the bottom. The degree of the polynomial in the top is 1, linear, and the degree of the polynomial in the bottom, in this case 2, is quadratic. By the way, this quadratic polynomial...
Hold on.
Hey, what is that? Putting off the microphone, please. This is the thing online. Okay. Okay, putting off the microphone. All right, Sandra. Okay, I know Sandra, you are here. Okay, so now the important thing to understand, well, I did a factored form, but in this case, no. Why no? Because this expression is prime. How do you know? It's prime. Well, it's prime because you try to solve for x. You force it to be 0. Now you discover I move forward to the other side, I get -4. When you apply square root, x is equal plus or minus 2i. It's imaginary. That means that the restriction, we have no restriction because in the real field, in the real or real number, from negative infinity to positive infinity, positive 2i is impossible to find. So the restrictions are imaginary, totally out. The all real number, remember the assumption to investigate the domain is you suppose at the beginning, gets all real number except the restriction. But when you find the restriction, so you get imaginary numbers or complex number, you only understand that the restrictions do not exist in the real field. So basically we have no restriction, therefore the domain is all real number. In this all real number, you put it from negative infinity to positive infinity, or you put in words all real number. So far, everyone follow me? Well, we have one more case, important, case the example 4, in which you see new situation. Suppose the function p is the name of the function, and p is formed by division two polynomial. The polynomial in the top is x minus 3, and the polynomial in the bottom is x squared minus 5x plus 6. Guys, I highly recommend when you start, so step number 1, step number 0 to analyze that kind of function, rational function, is expressed in factorial form. This is degree 1, stay the same, and this is degree 2, but this trinomial. So you break it down into binomial. Oh yeah, again noise. Fabiana, you make a noise, Fabiana. Okay. Therefore, the factorization in this case, I did that. Is x minus 3. I don't want to complicate. I put the same example. But the new thing that bring me this example is that this factor is cancelled. And the final answer is 1 over x minus 2. So, okay. Let me try to understand this new idea. So when you are doing the factorial form and one factor is cancelled, what means that? Well, the domain is the same. The domain is all real number except the restrictions. Actually, we have two restrictions, the restriction 3 and the restriction 2. So it's similar to this example. It's similar. X no 3 and x no 2. However, what's the new thing that brings me this? Oh, okay, one factor is cancelled and one factor is staying. The factor gets cancelled always is considered like a whole. So at x equal 3, we have a whole. I want to explain what is a whole. And the factor que stay is obvious, que es at x equal 2 is a vertical aspect. Very similar to the thing that we discussed before. It's the point. Let me try to do my best. This is not the moment to do graphic, but I try to illustrate this idea. Look, and this is 1, this is 2, and this is 3. So in 2 we have baric acid. Baric acid always is represent using dotted line, vertical dotted line, and black color. Y our curve, I suppose que I put in decimal, I put in red color, is something like that. Asymptotically in this direction, asymptotically in this direction, but in 3 happens something interesting. We have a hole, and this is the way to indicate the hole. It's obvious that when you evaluate the function p, is the name of the function, and 2, the answer is undefined. And the reason it's undefined is because at 2 we have baric acid. And also, when you evaluate n3, it's also undefined. But the reason is different, because in 3 we have a hole. So now the question can maybe fly in the air. So this expression, professor, is valid or invalid? Yes, it's valid, but in what condition? So this you can represent P like this expression is easier, no? To write like that or like that. But this idea is valid if X is not 3, because in 3 we have a hole. So in conclusion, in few words, we can use in this expression, yes, anytime, except in 3, because in 3 we have a hole. In other value, in 5 and 20, yes, it's better using the way after the simplification, not the origin. Do you understand the idea? Question? Come on, let me check the microphone, because everything on off. A ver, Pierre, Mr. Pierre. Microphone off. Okay. Everyone follow me? Do you understand very well the thing I tried to explain?
Yes, yes.
Okay. Okay, so let's try to, okay. Today is the day of theoretical part. No? I explain everything in detail. It may be in the last moment we are doing one entire example que integrate everything. But now to theoretical part. Let me try to explain now baric and little baric acid. Okay. Okay. The thing I tried to explain in baric acid was que our graphic is a curve approach but never touch this acid. But what is the idea? Suppose que we have, you determine que this is the x-axis, que at 2 hypothetical value, we have a baric acid. When you approach it to the left in that direction, it's easy because you pick one value less than 2, for example 1 or 0, and you evaluate the function in this. Suppose que the function is, I don't care the value, the value is negative. That means que our curve travel in that direction, negative. But you evaluate in this direction. Entonces you suppose you select 3 or 4 or 5, and you evaluate the function in 3, and the answer is positive. Positive 20, I don't care the value. And the asymptote look like that. We have actually, so the thing you need to understand is when the x approaches to 2, and you're using that symbol, que is not equal, it's approach. Approach means que is, for example, 1.99, 1.9999, o sea, close to 2 to the left or close to 2 to the right, que es 2.0001. The y value approaches to positive infinity in this direction or negative infinity in this direction. The notation que some book using, pero personally I don't like to explain in pre-calculus now, is you take x approaches to 2 to the left. Que es equivalent to say x approaches to 2 minus, pero this minus is no minus 2. So you need to understand the difference between this minus 2 and this minus small. This means when it's minus, superior minus is left. And x approaches to 2 right is x approaches to 2 plus. The plus is right, left is minus. But it's not important. In calculus, the teacher of calculus, of course, using this notation every day. Now, the important is that we have 4 possibilities. Look at that. We have 4 possibilities. Suppose the value of 2, hypothetical, 2. In 2, we have baric acid. Always we using dotted line. And we have, suppose we have that situation. Okay, the curve approach it here and approach it here. How we investigate? Easy. You evaluate 1 point before 2 and 1 point after 2. And you analyze the sign. Si es positive, si es negative, is this behavior, or si es positive both, is this behavior, or si es negative here and positive here is another behavior, or si es negative both is another behavior. One clue can give me information. Suppose the function here can look like similar to this is the function that is 1 over x minus 2. It's obvious. So you evaluate, for example, so you evaluate 3 minus 2 is 1, que es positive. So you evaluate 1 minus 2 is negative 1, entonces es negative. That scenario is, suppose 1 over, not necessarily 1, any number, x minus 2 squared. So when the power is even, square always is positive in both directions. And likewise, this is minus 1 over x minus 2 squared. And this is similar to this, but opposite sign is, you know, negative 1 over x minus 2. Okay, let's see a couple of the examples that include baric acid and holes. So far, no problem. Okay, you can interrupt me. Okay, example 1 of the baric acid. Suppose one function f of x is equal to over x minus 3. And what's the goal? Well, the goal is do the graph approximately, roughly sketch. So I determine, I take the expression at the bottom always. You enforce it to be 0 and x equal 3. And we have here a famous baric acid. And so what is the behavior? Because you have 4 possibilities, professor. Well, okay. You for example, evaluate a little bit before and after. Suppose you evaluate n4. Okay, 4 is greater than 3. It's 2 over 4 minus 3. 4 minus 3 is 1. And 2 divided by 1 is 2. The point is the point 4, 2. Because the x that you suppose at the beginning was 4, and the y that you get is 2.
Excuse me, I think your whiteboard is frozen.
For you or for everyone?
Oh no, at least for me.
Oh, so you need to do something. You refresh, reload, go out and get it again.
It's frozen for me as well.
Yes. I don't know. My internet is strong. The rest of the students, okay, guys? Come on, answer me. You have problem or no with the internet?
It refreshed.
Now it's changed.
Now I work.
Work. So that's your problem. Remember, it's complicated. This is you need to get good computer. You need to get good internet to take class online. I cannot solve it. This is technical. Okay. So now one possibility I hear some students can say, no, I go out, log out, and again click in the link. I get in again. Entonces better is because you know the internet is fluctuante. O sea, maybe es change the velocity depende de the company, no, and the price que you select the internet. Okay. Okay. So we continue. Okay, entonces now F evaluate 2, maybe. Why I select 2? Because the asymptote I want to investigate, look, SN3, 1, 2, 3. This is my vertical asymptote. Entonces yo evalué en 4, and the answer was 2. So I get that point. 4,2. Now I want to investigate a little bit before 3 get 2, maybe, or 1 or 0. Doesn't matter, it's totally arbitrary. 2 over. Entonces 2 minus 3 que es negative 1. Que entonces es negative 2. And the point is the point 2, negative 2. I plot the point. 2, this is 3, this is 2. Negative 2, negative 1, negative 2. This is this one. So I believe, using my common sense and imagination, okay, the curve look like that. Of course, we need to analyze more details, okay? In this moment, you don't know, but in your moment, you know very well. This is the x-axis, and this is the y-axis. Do you understand very well this example? Yes or no? Answer me. Yes?
Yeah.
Yes? Cool. Okay. Example 2. Bring me a new situation. Pay attention. Suppose the function g. I give you for this example, but I want to explain in detail now. Suppose que es given this. Okay. Remember, the first thing you should do is factor 4. The factorization, the top is impossible, and factorization the bottom is trinomial, is xx32. Minus both, therefore I can see okay, one factor is cancelled, and we have 1 over x minus 2. Okay, so I try to do my best in the graphic part. I detect things we have the whole. So one conclusion is we have a whole at x equal 3. So how do you know that? The factor gets cancelled is considered a whole because it's undefined but no asymptote. However, we have also a vertical asymptote at x equal 2, so the factor can stay after the simplification represent the vertical asymptote. So now let me try to do my best graphically of this. This is the y-axis, this is the x-axis. I know okay, we have one asymptote in 2. It's a 1, it's a 2. We have vertical asymptote here. In 3, we have a hole, but I don't know exactly how. And just in 4, let's see. So in order to understand the behavior, you evaluate left and right. Suppose left is G evaluating 1, because the asymptote is in 2, no? The G evaluating 1 is, you take the original expression or you take the nice expression after the simplification. Remember, this expression and this expression are equivalent 100% except in 3. In 3, no. Because in 3 was a factor is gone. Yes, a whole. And you can use in this. It's easy. 1 over 1 minus 2 is 1 over negative 1 is negative 1. And the point is a point 1 comma negative 1. Let me plot that. 1 negative 1. Here. It's a point 1 comma negative 1. Okay, I know very well. Okay, we have here the baric acid. That is continue for forever to negative infinity, of course, but never touch the acid. This is approached asymptotically. That means that the distance between the curve and the acid is small, but never 0. Asymptotic. Likewise, if you evaluate in 4, not in 3, because in 3, you know that we have a problem, no? You select arbitrary, you select 4, 5, 6, any value, but in 3, no, because in 3 introduces me problem. So it's 1 over 4 minus 2, no? Again, one more time, I plug in here, entonces 1 over 4 minus 2 is 2, okay, 1/2. Entonces the point is a point, 4 comma 1/2. Okay, this is 4, this is 1, this is 1/2, in the middle here, the point is this. Entonces, I suppose que my curve, similar to this, but in this case, go to the infinity. Okay. Now the complicated part. Not complicated, the weird part. Look, I erased that. Why I erased that? Because we have a hole. The hole approximately, well, let me try to put the curve. No, it's okay. The curve. However, we have a hole. No, I don't know exactly where, but it's a hole. And the hole is indicate like a circle, empty, because it's to be undefined the function, no? That the y value do not exist for 3. Okay, this is the way to indicate that. This idea is clear or confusing?
Clear.
But I want to, go ahead. Any question? Clear, right? Let me try to show you, as always, the Desmos script. Can you see exactly the same graphic that we are doing by hand in the whiteboard, but more elegant, no? More clear. Let me try. You share, let me see. Share, switching to the Desmos, rational function, Desmos script. Okay. Do you see Desmos? Do you see or not?
Yes.
Look at the example, my first example today. Bang. Okay, I just copy the function, you put f of x, so you put y, either way. The only advantage to using function notation is that you can evaluate directly. Evaluate in 4, plugging in, and 2, plugging in, and you plot the point. And you see clear, okay, in blue color, I put my curve, I put 2 points, and we compute by hand in the whiteboard. And the vertical asymptote is at x equal 3. In this case, yeah, x equal 3. And normally the convention to do the vertical asymptote is black color dotted line. Guys, you are doing this in your test, and you click here to share the graphic. Let me see here, right? And export. And this is the graph, and you send me attached to the written test at least, no? You download in the format you prefer, like image, no? or PDF, I suppose. Let me see. There are different kind of image. So you don't need to do the graphic by hand and the piece of paper. This is the antique thing. Now everyone doing the graphic using software. Okay. This is the example 1. Was clear? Now example 2. Example 2 is more complicated because we have the whole. Look at that. This is my graphic. Again, I'm using blue color. And important was the point this. Okay, actually, this point 3,1 belong to the function that one. Okay, it's 1 over x. So look. This is the original in blue color. And this is the other after the simplification of the whole. Look, it's the same. What is the only difference? Okay, these have no hole, the red one, and the blue, yes. Clear? Entonces es important. O sea, any detail is important in this. The asymptote, the holes. Okay? Any question? What part you don't understand very well? Everything okay? Sure?
Yes.
Cool. I saw in the first test that we have here brilliant students. I suppose that another student try to do your best for the second test. Remember, repeat one more time. The way to study is, you are doing the homework. The homework is unlimited. Si I see in one homework that you don't finish, I understand that you are lazy student. That you are doing the homework. When you stop in one question, you send me the screenshot. Yeah, I explain. This is the way to study. Okay, at least the online part. The written part, no. The written part we discussing in the review. Okay, I suppose that today we have no holiday, no? And we finish the holiday, the review. Okay, let's come back to the whiteboard one more time. Do you see my whiteboard or not yet? Do you see or not?
Yes.
Okay, I want to erase everything, guys, because I want to explain another topic important, is the horizontal asymptote. Don't frustrate. We have 3 kinds of asymptote. We study vertical. Now we start studying horizontal, and we have one more. Horizontal asymptote. Okay. This is very easy to understand, in my opinion, because it's similar to the end behavior. Remember what is the end behavior? The end behavior is you're supposed to, when the x approaches to positive infinity, or when the x approaches to negative infinity, happen that the y value of the function go to the specific value. This is the end behavior. End behavior is because x is huge number, positive or huge number negative. And the y value, I don't know what happened. I want to explain now. So this is the idea behind the horizontal. We have different scenarios. Suppose these 3 cases. Actually, we have more, but I put the more representative case you can find. Look, suppose in red color, my curve. Suppose, well, no. Suppose in black color, the horizontal asymptote. Okay, as always, we are doing a dotted line. Black color. Now the curve, I suppose, look like that. And you know how approach it asymptotically to the asymptote. And in this case, no touch. The distance decreasing, but no touch. Okay, another scenario when we have vertical, okay, very popular, and horizontal. By the way, I forgot to say, que the equation for the horizontal, because it's a horizontal line, is y equal any number. However, and the equation for the vertical is x equal any number. X equal 3, x equal 4, y equal 3 is a horizontal line. And suppose that we have this curve. Es approach to the vertical y approach to the horizontal. Approach to the vertical and approach to the horizontal, pero never touch. Suppose another scenario in which it's possible touch at one specific point the horizontal and continue after asymptotic approach asymptotic. And this is an important point in the case it exists that point. It's called the crossing point. Yeah, I want to explain how you determine the crossing point. So it's important that when you analyze the horizontal asymptote, you analyze number one, exists or not. Number one. Number two, at what value? Number three, crossing or not. Okay, this is the thing we investigate now in different examples. Example one of the horizontal. Suppose this example is easy. F of x is equal 7x squared plus 2x divided by 4x squared minus 3. Okay, super important. Do the degree analysis. I call it like that, degree analysis. What is that? What is the degree of the polynomial at the top? Is 2, because the exponent, the higher exponent. What is the degree in the polynomial at the bottom? Is 2. When this situation happens, okay, it's the regular situation. If the degree 1, let me call degree 1 on the top, is equal, same degree, degree 2, the conclusion is, yes, we have horizontal asymptote. So one analysis, degree analysis, is you analyze the degrees. If the degree is the same, yes, we have horizontal asymptote. Let's see if the degree is different. But so far, 100% you can affirm it. If the degree is the same, we have horizontal. At what value? This is my first question. Exists or no? Yes. The second point is, at what value? To determine the value is super easy. So the horizontal asymptote is located at the equation y equal, and you divide this number divided by this number. You divide the leading coefficients, is 7/4. Okay, because what is the reason? What is the reason? It's easy to understand. Look, this is a polynomial, 7x squared plus 2x. And this is another polynomial, 4x squared minus 3. But this polynomial on the top is formed by quadratic and linear. And this is increasing, of course, but this is increasing faster because it's a square. Therefore, you can consider it that this is the dominant. And likewise, it's constant, no increasing. So basically, the dominant in the top and the bottom always is formed by the monomial that have higher degree. It's obvious that that part is cancelled and this is 7/4. Bang! Easy. Yes or no? Now the third is, exists or no the crossing point. Well, let me try. What is the analysis of the crossing point? It's easy. You take the original function that's given at the beginning. You determine the asymptote and you enforce it to be equal. So in other words, the thing we are doing algebraically is, if the red color curve coincident in any point with the horizontal asymptote. Sometimes happen that this equation I try to solve it have no solution. That means that we have no crossing point. In this case, yes. In this case, we have solution. Let me try. This is easy. You apply cross multiply. Multiply this and this, and multiply this and this, because it's proportion. So you multiply 4 times 7x squared plus 2x equals 7 parentheses 4x squared minus 3. And you apply distributive property, 28x squared plus ax is equal to 28x squared minus 21. Okay? There's no coincidence. It's all frequently happen. The parts cancel and stay ax equal 21. Therefore, x is equal to 21 divided by 8. And this is the value for the, pero es negative, no? It's negative, it's negative. Sorry, I forgot the negative here. It's negative. And the point is, the point minus 21 over 8, comma, and what is the y value, guys? Help me. Of the crossing point. Yeah? So you don't know it's because you don't pay attention. What is the y value of the crossing point?
7 over 4.
Exactly, 7 over 4. Get the y value of the horizontal. Do you understand very well? The 3 points we analyze. So we are doing the analysis of the degree. Si the degree is the same, si it's different, let's see what happens. But so far, no. I bring 2 more examples, and you help me to understand this. Example 2 and example 3. I want participation. In example 2, we have h of x equal 8x squared plus 9x minus 5 divided by 2x squared plus 1. In example 3, we have p of x is equal x squared plus 7 over 11 minus x squared. Okay, 1, 2, 3, 1, 2, 3, 1, 2, 3, in each example, 1, 2, 3, 1, 2, 3. In the first part, number 1 point is just answer, yes or no. In number 2 example, we focus in number 2. Help me.
Yes.
Yes. Why?
Because D1 equals 2.
Say again. Because? What is the reason? Mister, I don't hear the reason. Because what? What happened? Your computer broken.
Equals
4. What? Equal what? Equal 4.
4.
Okay. Yes, okay. The reason is because we have the same degree, no? Do you see that or no? Everyone saw that or no? O sea, degree analysis. This is dominant. This is dominant. And he said also que y equal 4. Where come from 4? Where come from that 4?
8 over 2.
Exactly. It's 8 over 2. You divide 8 divided by 2 is 4. Let's do in painting because it's too long. The number 3 of the crossing point. It's not important for me now. Let's move on to example 3. Example 3. What do you think about number 3? We have or we have no? Yes or no? Another participation. Come on. Yes, no.
No.
Yes, no. No. Why no?
Oh no, it's
Reason.
yes, because
Yes,
for the
it's
degrees
tricky.
match.
Exactly. It's tricky. I put intentionally to confuse you. So what is the dominant? So remember, we are doing the analysis of degree. And degree in the top is 2 and degree of the bottom is 2. It doesn't matter the place. It's not totally irrelevant. It's the highest point. Where's the highest point? 2. Entonces the answer is yes. By the same reason. Same degree. Entonces, a what value is the horizontal? A y equal what?
1/1.
1 over negative 1.
Yes, -1.
Yes, it's negative 1. Cool. And the crossing, let's do in another example. Okay, I have another. And you let me know. Example, this is 2, no? This is what number is this example? 3, 4. Another example. 4. Example 4. Guys, this is easy. Only pay attention and try to understand. Suppose 8x squared plus 9x minus 5 divided by 2x squared plus 1. The only thing in the number 4 we are doing the 3 step, 1, 2, 3. So we are doing crossing points. Number 1, analysis of the degree. Yes or no?
Yeah.
Okay. Yes. Exist. So conclusion is exist the horizontal because it's the same degree. Degree 2. At what value? Y equal
4.
4. Again, 8 divided by 2 get 4. Coincident. Well, another example. Now let me try to find the crossing point. Crossing point is always a little bit more complicated. So you copy the function that's given at the beginning, and you investigate if it's possible or impossible to be equal 4. It's our value of the horizontal aspect. You apply cross multiply one more time. 8x squared plus 9x minus 5 is equal 4 times, parentheses, 2x squared plus 1. Okay, now I apply this derivative. This is 8x squared plus 4, no? And this is cancelled. Not always happen, but in this case happen. And we have an 9x minus 5 equal 4. We solve for x, linear equation, easy. 4 plus 5 is 9. Divided by 9 both sides. It's obvious, yes, it's x equal 1. So the point, the crossing point is the point 1 comma something. 1 comma what?
4.
Exactly, it's the y value of the horizontal. How do you feel in that part?
Good. It's easy.
Easy, it's easy. I told you. Now I want to illustrate that not always when the degree is the same, yes, 100% you say yes. However, we have another special case. A special case of the horizontals. So the regular, every day we see that is when it's the same degree. However, we have another scenario. For example, suppose h of x equal, this is example 6, no? Equal 5 divided by 4x squared plus 9. Okay, so we are doing again the analysis of the degree. The degree here is 0 because it's constant, no x. So do you understand very well what is the reason it's 0, no? You can consider 5x to the 0. X to the 0 is 1. That is the reason que es invisible. Degree 0. And here, degree is 2. Entonces, if the degree 2, que es denominator, let me call degree 2, denominator 2 is greater than degree of the numerator, que es 1. The conclusion is, yes, we have. But we have a special horizontal. Special. Our value, guy, always is a y0. When it's special, when you're detecting que es special, always is a y0. And the reason is clear. Suppose que you divide any number que conta, this number stays the same, never increasing, stay constant, divided by something que increasing. Es obvio que the quotient of this is smaller, but never is negative. Just approach to 0. This idea is clear or no? Or you need extra explanation?
It's clear.
It's clear. So no negative, but it's smaller. So what are the conditions here? So keep in mind, in the problem, in the exact side we have, that you have a special case when the degree of the denominator is bigger than, but bigger than 1, 2, 3, 4. Suppose another example, okay, suppose the function p, okay, we have, for example, x cubic, and we have x to the 5th, plus x to the 2nd, plus x plus 10. We are doing the analysis of the degree. What is the degree of the top part? Degree 1 is 3, no? And degree 2 is 5. So the answer is, we have or no?
Yes.
Yes. At what value?
Y equals 0.
Exactly, because it's a special. Because the degree of the denominator is bigger. Any question? What part is confusing? Oh, today we are doing good and fast. I like this class. Okay, so we start the last accent, que es called slang accent. Slang is like an oblique line. So slang accent. So far, we are studying the vertical. We studied the horizontal. Okay, by the way, this is x equal 1 number, 2, for example. This is y equal 1 number, suppose 5. But the slang asymptote is inclinate. So the equation is different. The equation is look like y equal mx plus b. Not necessarily positive slope, maybe negative slope, maybe in the other direction. But it's a slang. And how you determine and how you know the condition can exist this guy. Suppose this hypothetical example, number 1 for the slang, is f of x equal x squared plus 1 divided by x minus 1. Okay, because always we are doing the analysis of degree. Degree 1 is 2. Degree 2, que es denominator, I call 2 denominator, I call 1 numerator, es 1. Oh, entonces if degree 1 is greater than or no greater than equal degree 2 plus 1. So in other words, degree 1 is 1 more than degree 2. So the degree of the our denominator was 1 plus 1 is 2. Entonces, si es Si es, suppose que es, this degree is 3 and this degree is 1, no. One more. This degree is 3 and this degree is 2. So one more, 2 plus 1 is 3. Entonces, yes, we have the condition. Entonces, yes, we have a slant asymptote. Do you understand the idea? O sea, the degree of the top is greater than, pero 1, or the degree of the. This is the only condition. And it's obvious que this condition is completely excluded the horizontal. Because the horizontal, we have only when it's the same, equal, or when the degree of the top is, the bottom, sorry, D2 is greater than. Entonces, horizontal and slant, there are two conditions that are mutually exclusive. Si we have horizontal, we have no slant. Si we have slant, we have no horizontal. And vertical, no. Vertical is totally independent. We have vertical and horizontal, we have vertical and slant. But never you have slant and horizontal together. It's impossible. Mutually exclusive. Okay. Now how you find the equation? So the equation is a little bit complicated. Not too much, but it's a little bit. So for finding the equation of this slant asymptote, we need to perform the long division. You need to perform the long division. So you write in that format, okay, the format for the long division or synthetic division. I want to explain both, and you decide what way you prefer. You copy the top part inside the box, x squared plus 0x, because 0x is missing. So we have polynomial degree 2, but degree 1 is missing, and degree 0, yes. I copy this. This is important to complete that, because we have the column of the x squared, we have the column of the x1, and the column of the x0. And you divide it by x minus 1. And you perform long division. Let's do it. It's easy. It's x, because x times x is x squared. And x times -1 is minus x. By subtracting, you change the sign. This is cancelled, and this is x. Plus 1. Bring down 1. Now here is plus 1. Why plus 1? Because 1 times x is x. And 1 times -1 is -1. By subtracting, change the sign. And cancel out that part, and the answer is 2 the remainder. Okay, perfect. So clear. Okay, this expression, okay, at the beginning was x squared plus 1 divided by x minus 1. I can modify using long division. And the quotient, okay, is this expression. I copy first. Plus, and the remainder, because this is 2, over divisor, because this. I copy here, x minus. What is the formula, guys? The formula is P over Q is equal quotient plus remainder over divisor. In our specific example, the quotient is this guy. The remainder is 2, and the divisor is x minus 1. Okay, cool. So this is just algebra. We are doing only modification using one specific technique of algebra. Okay. So this is an important moment. I can recognize that part is the slant asymptote. Why? Because it's linear. Our slant asymptote is y equal x plus 1. Bang! Yeah, I plot that. Suppose I need to do the graphic. No, it's tricky now. Now to get the rough idea, XY, I put a line. The line is easy. You are familiar. 1 is B. Therefore, 1 is the Y in a set. 0, 1 is the Y in a set. And the slope is also 1. So 1, entonces wrong right is 1, entonces 1 over and 1 to the right, and you are doing the famous slam. This is our slam asset. By the way, so you integrate everything we studied today, of course. And this moment we have, at the beginning, I know very well, okay, we have also a vertical asymptote, get this. So we have a vertical asymptote. You take the expression in the denominator, you force it to be 0 at x equals 1. And 1, here, we have another vertical asymptote. And this problem, we have two, slant and vertical. And the rest is try to do the graphic I want to explain in detail after this. The graph look like that, approximately. Remember, the asymptote is important piece of the graph because help me to understand the graphic. The graphic, of course, always is the red part, but the asymptote is auxiliary construction can help me to understand the behavior of this. By the way, the students are good and like to do synthetic division. You can do this long division. It's a long division. Long division is universal. Division. Long division is universal. And always we can use in when you want to divide any polynomial divided by another polynomial. It doesn't matter the degree. However, synthetic division is easier, but it's limitation only when the denominator is linear. It's exactly the thing we're using in determining the polynomial function, really. I suppose you remember very well. And you copy the coefficient. See, the coefficient is 1, 0, 1. Look at that. 1, 0, 1. I don't care x squared. No. I don't care. Yeah, I copy outside 1, but opposite side. You remember guys, the idea behind synthetic division is different to long division. In long division, the procedure is complicated because you multiply, subtracting. You need to subtract it several times. In this case, no. In this case, you change the sign one time, and that's it. It's equivalent to subtracting several times. So you bring down 1, multiplication 1 times 1 is 1, 1 plus 0 is 1, and 1 times 1 is 1, and 1 plus 1 is 2. Oh, and this is my remainder, get 2, look at that. And the rest is the polynomial quotient, is x to the 0 and x to the 1, okay, by the way, is y equal x plus 1. Cool? Do you see very well or no?
Yes.
Cool. Now, this is a crucial moment. Okay, we are ready. Do you want to do one more example of this? Yeah, slam.
Yeah.
I believe it's good. I have another. Okay. Suppose this. Example 2 of the slam. Suppose the function g is equal to x squared minus 5x minus 3 divided by x minus 2. Okay, we are doing the analysis in two parts. Part 1 determine yes or no, and part 2 determine the value of this. So this is yes or no question. We have a line yes or no, slam is my problem, slam question mark. And after determine the equation for the slam, y equal mx plus b. Do you understand the goal? Do you understand the goal?
Yeah.
Cool. So remember, to analyze that, you analyze degree 1 is 2. And degree 1 gets denominator. Sorry, this is degree 1 and this is degree 2. Sorry. A1. What do you think? We have a slam, yes or no?
Yes.
Yes. Remember, the condition to have slant asymptote is the degree of the numerator is equal the degree of the denominator plus 1. Otherwise, no. But in this case, yes, because 2 is equal 1 plus 1. Okay? Everyone follow me?
Yep.
Now the rest is find the equation for the slant. Entonces I ask you, you prefer long division or you prefer synthetic division?
Synthetic.
Yeah, me too. Entonces, the format for the synthetic division is you copy that symbol, you put 2, -5, and -3, no? And outside, you put 2 positive, no? Yes or no? Completely opposite sign to this. In long division, no. In long division, you put x minus 2. But in synthetic, no x. I omit the x. I omit the sign also. It's doing. Entonces, bring down 2 without do anything. Multiplication 2 times 2 is 4. This is -1. And -1 times 2 is -2. And this is -5. Okay, this is a remainder. The last column is always the remainder. Now the equation for the slant is 2x minus 1. So this is 2, is this 2, this 2, is this 2, and this -1 is this negative. By the way, I have another question. Completely out of the game. Is we have vertical asymptote, yes or no?
Yes.
Yes. Why? How do you know? I agree with you 100%.
Because
What is the formula for finding the vertical asymptote? Don't worry. I refresh your memory. Remember, you have P divided by Q. Polynomial. The formula to find the vertical asymptote is you take Q, the polynomial at the bottom, and you force it to be 0. In our specific example is x minus 2 equals 0. Therefore, at x equal 2, we have vertical. So in this case, you have two asymptotes, one a slant, another vertical. Let me try to do my best. The vertical is in 2, 1, 2, like that. The equation is x equal 2, and the other is this, que es 2x minus 1. I can see que the y in el set is -1. -1, I suppose, que is here. It's a point 0, -1. And the slope is 2. So 2 and 1 here. We're connecting. I suppose that you know very well how we are doing graphic of the line, no? Normally, in more detail, you put in decimals, and decimals give me one idea like that. Yeah, sophisticated detail, 1 point here, 1 point here, you see in decimals. Okay, cool. Any question about slant? Just I need now integrate everything. Therefore, important. This is the most important moment today. I want to get you a guideline to graphic rational functions. And what is the idea behind graphic? In the test, there are at least 2 questions. It's graphic. Rational. Functions. Okay. Let me make it zoom. Yeah, I want to explain. Guys, it's 7. I organize in 7 points. I appreciate so much when you are doing this job, doing the graph. you are doing the 7 point. 1, 2, 3, 4, 5. I organize like that. The first one is factorization. So in other words, express it, the rational function in factoring form. That you factorization on the top, you factorization on the bottom. Entonces, en this es important because, suppose, example, suppose que you have different factors. X minus 2, x minus 4, x plus 5. And the bottom we have x minus 3, x minus 6, and x plus 5. Not always happen this, but sometimes happen, maybe. Entonces now you detecting, wow, these factors cancel out. Entonces the factor gets canceled out as a whole. And you know the whole you represent in the curve something like that. And this whole is located at the point x equal -5. Okay, completely opposite sign of the factor, no? And stay alive, in the denominator 3 and 6, que represent the vertical acid. Vertical acid at x equal 3 and x equal 6. That's a hypothetical example. Do you understand very well this first step, factorization? Yes or no?
Yeah.
Cool. Number 2.
Yes.
Yes. You see, long yes. Okay, so now the second important. I want in this order, guys, determine or find y-intercept. Oh, it's easy. I remember very well that. In order to find the x-intercept, you evaluate the function n0, and that's it. This is a mnemonic device to remember what is the formula of the y-intercept. Number 3 is find the x-intercept. So what is the formula, Professor? Well, the formula is f of x equals 0 in general, no? But specifically in rational function, que es one polynomial divided by another polynomial, and this is equal to 0, it's obvious que in this computation, Q doesn't work. Q is totally irrelevant. This is equivalent 100% to say que P is equal to 0. So I focus, so the 0, que es the x-intercept, the responsibility is the P part, and Q no. Q don't know participate. You understand very well this or no? So basically, you take the polynomial at the top, you are doing scientific division or whatever you want, and determine the solution. Maybe factorization or combination both, and determine the zero. Do you understand the idea, guys, or no?
Yes.
Yes. Number 4 for me is crucial. This is the most important mode. We have 7 steps, but number 4 is the most important. So number 4 is determine vertical acid. Okay, so what is, Professor, what is the formula for the vertical acid? Well, it's easy. The formula for the vertical acid, you take the polynomial Q. Of course, I take the Q after the simplification and the scenario that exists, and you enforce it to be 0. You see, it's completely opposite to this. So in this moment, I solve this equation. In this moment, also, I take advantage. I put the line that represents all real number. Let me try to use the rule. This line, 0 degree, represent all real number x value, 0. And this moment, I always doing this. And you, for example, this is the all real number. This is infinity, positive. This is infinity, negative. Suppose this in the middle is 0. And suppose hypothetical this example, I put in 3, 1, 2, 3, we have vertical acid. 4, 5, 6, we have another vertical asymptote. And suppose that the solution of this, the solution of this is x equal to and x equal 4. How do you know that? Look at this. In this example, I can put at the beginning. It's the 0 of the top, not including the whole. The whole no, the whole is undefined. So we have in 2, we have one x in a set, in 4, we have another x in a set. So what is important to graph it that? Because in the last point, get number 7, definitely to complete the pictures, we need to select totally arbitrary x value to evaluate the function. So the challenge is, Professor, how many points we need extra? Well, depending on the problem, guys. My answer is depending on the problem. As you are doing this analysis, you need to understand that you select one guy after the 6, maybe 7, maybe 8, maybe 9, I don't care. So this is a partition of the all real number line can help me to understand. You select one here after the 6, so bigger than 6. You select 5, it's in between 4 and 6. You select one here, no here, sorry, one in between 4 and 2, 3 maybe is good, and you take one guy, one value before 2, get maybe a 1 or maybe a 0. I like 0 so much. So to answer the question is, in this problem, you need at least 1, 2, 3, 4 additional points. Additional point to make a decent graph. Okay. And the problem, you see how I solved that. Okay, we almost finished. After that, important. The most important, number 5, is the analysis of the horizontal or slant. What is the reason I analyze both together? Because they are mutually exclusive. See, we have horizontal, we have no slant. See, we have a slant or horizontal. So you analyze both in one point, number 5. And you are doing the famous degree analysis. In the degree analysis, taking one more time this problem, I understand that degree 1 is 2 and degree 2 is also 2. Because it's a multiplication, no? I don't do that, but it's obvious, no? The aim behavior is, remember, to find the aim behavior, you delete mentally the constant. So we have 2x, x squared, and you have x squared. Wow, so I see que it's the same degree, so d1 equal d2. Do you see or no?
Yeah.
Entonces, what is the conclusion? We have horizontal or slant? Horizontal. And the rest, I don't need to explain. I want to explain a specific example. And you need to determine what value. By the way, in this case, 1. Because coefficient here is 1 is 1. Add y equal 1. And you determine the famous crossing point. Don't forget this guy. Because this is important point. In the scenario, okay, this crossing point exists. It's important to find that. And number 6, the majority of the students forgot number 6, but it's extremely important, and I want to explain why. It's the symmetry. So you spend 2 seconds, only 2 seconds, to analyze the symmetry. And remember, we have 2 kinds of symmetry. You have, for example, to make symmetry, you replace in my function x for negative x. So we have 2 possibilities, or actually 3 possibilities. One possibility is that the function stays the same, doesn't change. The only situation happens, the function is even. Another possibility is completely opposite signs. And when it's this situation, the function is odd. But this is special. A scenario, special symmetry. It's different, of course, but it's special. Because the most popular is not special, it's ordinary. When you replace x for negative x, never you get a relationship each other. And this is called neither. Neither, whatever you want the pronunciation. So what is important? The important is because you take advantage of this. How you take advantage of this? Suppose that my function is even a scenario. So now when it's even, it's symmetric with respect to the y-axis. So suppose one function is like that, and you determine algebraically que es even. Entonces I suppose que the graph look like that. Therefore, when I select here the additional point, and you select, for example, that point, okay, que es 1, que es 2, que es 3, and you determine the corresponding y value for each, plugging it into the original function. You don't need to select -1, -2, and -3 because it's the same. Because you proved before that the function is even. Then you save time. You need to do only the positive part. In my opinion, is more comfortable, in my opinion, because I know that the negative part is exactly the same y value. However, see the function is odd, the situation is similar, a little bit different. Suppose the function is like that, and the function is like that. So when you select the value 1, 2, and 3, and previously you analyze that the function is odd, you know that the y value is opposite sign. So suppose in this case is 1, entonces -1 would be -1, -1. It's opposite sign. This sign indicates also it's opposite sign. Therefore, it's easy because one more time you need to compute the positive part because I know, according to that kind of symmetry, that the negative part is exactly the same value but opposite sign. Okay? And unfortunately, si it's neither, entonces you need to do separately the positive part and the negative part. Now, some students omit that step. Okay, I agree. I understand. However, need to plot always positive and negative. Okay, it's a one possibility. And number seven is the additional. O sea, es plot. Additional points. The question can fly in the air. How many, Professor? So I explained before here. Depending on the example, you determine intermediate value in between the partition that is formed by vertical asymptote and x-intercept. In this case, the minimum is 4. And you select 5, better. 6, much better. 7, much better. Oh no, you believe that con 4 is enough to understand, to explain the behavior for this. Do you understand? Sure? Okay, suppose you have a lot of questions, but we're solving this question in this example. Okay, bring for you. Okay, this is example 1 after the guideline. Okay, I want to explain in detail, step by step. F of x, this is the crucial moment that I integrate everything we studied today. Okay. What is the step 1? Well, the professor explained that the step 1 was the factorization. Okay. Because in the factorization, detecting if we have whole or no. Okay, in this case, it's easy because in the top we have monomial, stay the same. But in the bottom we have binomial, but a special binomial is the difference of a square. And you apply the formula you know very well. A squared minus b squared factorization is a plus b times a minus b. In our specific example, square root x squared is x, and square root 4 is 2, plus or minus. And you can see in that moment, wow, no factor is cancelled out. Therefore, we have no hole in this problem. Cool? Everyone follow me? Factorization and detecting no cancel out anything, no hole. In other example, yes, we have hole. What is number 2? Well, number 2 is find the y and z. It's easy. Evaluate the function as 0. Replace x for 0. 4 times 0 divided by 0 squared minus 4. 4 times 0 is 0, and 0 squared is 0, minus 4 is minus 4, but 0 divided by negative 4 is 0. Therefore, the point is 0, 0. In this case, it's a coincidence. It's a coincidence when you see that both, well, the origin, 0, 0, is because that point, at least, that point is both. It's x and z and y and z. But just in case, I need to investigate, see if we have more x and z. In this example, no. But in other example, yes. Depending on the complexity of the polynomial in the top. But the function is f of x equals 0 as the formula. But I explained that this is equivalent to say p of x equals 0. And who is p of x? P of x is 4x equals 0. So you reduce the complicated problem in one easy elementary equation, divided by 4 both sides, x equals 0, and we get the same conclusion. We say that 0, 0 is the only point that crosses y and z and x and z. No more. No more. Everyone follow me so far? Yes or no? Come on, I want to try to finish this today. Okay, very gas. Okay, very gas. Remember the formula, you take cube x equals 0. No say you have two possibilities. You have possibility to take this polynomial or the factory form. Either way, I don't know why I prefer the original. Because it's the same, but it's okay. For me, I need to make a decision. No? You solve for x as a quadratic equation, apply square root both sides, and solve you get plus or minus. Okay? Okay, now, this is important moment, important, in which you are doing the partition of the all real number line. This is my all real number line. Infinity positive, infinity negative, and we so far investigate that we have here n0 x in a set, in positive 2, in negative 2, we have two vertical asymptotes. You say, I propose you, in the number 7 step, well, you select one point here, maybe 3, maybe 4, I don't care. Here, maybe 1, or maybe 0, or maybe negative 1. No both, and negative 3. So basically, I need to make a decision. I want to select 3, 1, and negative 3. Okay, you reserve that value for the last moment. This is very, very representative of the interval. Okay, wait. I make a mistake. Look at that. You select 1 and negative 1. Because actually, we have one partition. Let me use blue color. 0 partition, look. 2 partition, and minus 2. So I select one guy after the 2, and between 0 and 2, and between negative 2 and 0, and before negative 2. Sorry, 4 points we need. Okay, number 5 is slant or horizontal. I need help. Look at the equation. What do you think? We have horizontal or slant?
Slant.
Slant. I don't think so. What is the analysis of the degree? I want to copy again. 4x. Guys, you need to remember this idea. What is the degree 1? Degree 1 is 1. And what is the degree 2? Degree 2 is 2. What's going on when the degree of the denominator is bigger than the degree? ¿Es horizontal or es not?
Horizontal.
Absolutely. But what kind of horizontal? Special or regular?
Special.
Exactly. Special. Now, what is the value for the asset? Y equal? What is the value for the horizontal? No idea? Nobody?
Y equals 0.
Y equals 0 because it's a special. Special case. By the way, I need to investigate the famous crossing point. Okay, I need to investigate if my original expression is equal or no to 0, que es the value for the horizontal. But this equation I solving here in the point number 3, remember, indirectly, but I solve it. Okay, 0. The answer is 0. Okay, 0, wow, it's a very important point in this example. Is y in a set, x in a set, and also crossing point. And you see clear when I finish the problem. Okay? Everyone follow me? Yes or no?
Yes.
Okay, symmetry now. I need to investigate. See, we have symmetry because if we have symmetry, I take advantage of this idea. So you replace x for negative x in the original equation. It's 4 times minus x divided by minus x squared minus 4. Be careful with the sign. Positive 4 and negative x is minus 4x. In this case, change. But in this case, no, because the square becomes positive. And we compare this expression and this expression. That one. It's the same? It's the same?
No.
No. Therefore, no even. Even is when it's the same. Is opposite sign, completely opposite sign? Yes or no?
No.
I believe que yes, mister. Why? This is confusing. I understand very well. Get confused. Remember, it's a fraction. One fraction is 4x divided by x squared minus 4. Another fraction is minus 4x divided by x squared minus 4. Okay, this is equivalent to put this minus in the front. Yes or no?
Yeah.
When you have fraction, entonces you put a negative in the numerator or in the denominator or in the middle, it's equivalent. There are 3 different ways to express the same idea. This is my f of x. And this is my minus f of x. Do you see? Entonces, this is obvio que es odd function. Do you see que es odd? Do you see que es odd? Do you understand que es odd? Yes or no? No. Okay. The confusing part, I understand. When you have 2 over 5 and you put a negative in the numerator, it's equivalent to say 2 over negative 5. Yes or no? Yes, equivalent to put negative over 5. Yes or no?
Yes.
The condition for the odd is que f and negative x would be equal minus f of x. That magically happens que the negative inside the parentheses go outside the parentheses. This is the condition for the odd. It's exactly the same happen. You replace x over negative x and magically I put the negative outside. Do you see or no? No?
Yes.
Okay, cool. Now, The rest is evaluate, but I want to skip that part because it's super easy. And I want to show you in Desmos the answer. There you go. Let me share with you Desmos. Okay, look at that, look at that, look at that, look at that. Let me share the screen. Desmos demo for you now. This is the graph of the first example we are doing today. Complete and integrate everything. Desmos. Do you see Desmos?
Yeah.
Okay, recap. Recap. This is my function. I select green color, blue color. I determine, remember the vertical azimuth at 2, a flashing at -2, and also the horizontal azimuth y0. Look at that, flashing. No slant. And the points I select was 4, 3, 0,0, que es the y and the z and x and z, and crossing point. Look, because cross it, the horizontal azimuth. Super cool. Do you see how I integrate? I promise the next time we are doing one more or two more examples. Let me see, 1, 2, 3 examples of this. Can integrate everything. That's exactly the thing you should do in the written test. Cool? Okay, guys. Have a nice day. See you Monday. Okay, continue studying, everyone.
Have a nice day.
You too.